Hello viewers, welcome to projection of lines session 11. Here we'll do the problems on midpoint, that is projection of lines with reference to midpoint operation. These things, the basics of this I've already told you in the last session. Again I'm going to repeat in this session also before starting with the main problem on midpoint. Here, the midpoint of a line AB is 40 mm from both the planes. The line is inclined at 30 degrees to HP, 45 degrees to AB. Line measures 100 mm. Here, the midpoint of a line AB is 40 mm from both the planes. Now you see here, the midpoint, this line is referred to midpoint, not one end point. Okay, please understand, this line is referred to the midpoint. This can be anything. Whatever may be the amount, whatever may be the distance, the projections won't change. But whatever is the thing given, you should take it. Okay. But the reference is for the midpoint of the line, but not for the end point of the line. So far, we are doing for the end point of the line. Okay. Now, the three parameters are the line inclined at 30 degrees to HP, 45 degrees to VP. That is theta is given, phi is given, and true length is given. In that way, you have to do the projection. Okay. Anyway, I'll tell you the basics. Here you see here. Here, so far, what we are doing was, see here the line PQ, red color, okay, 30 degrees to HP. For this, corresponding front view was here, corresponding top view was this black PQ and P dash Q dash. Front view was P dash Q dash, top view was PQ. But here I was fixing P, that is fixed point was P, moving point was Q. P I never used to change, okay. P was 40 mm in front of VP, 20 mm above HP, as you see, 40 mm in front of VP, 20 mm above HP. Okay, now it is inclined at 30 degrees to HP. If you want to give inclination to VP, I used to move only Q, either this way nearer to VP or this way nearer to the observer, when the line will be inclined to both the planes. Keeping 30-degree constant only, I used to move this way or this way so that the line is inclined at some degrees to VP, so that the problem becomes line inclined to both the planes. Okay, please understand, here I used to fix only P. P now I never used to change. Whatever is the distance we used to take. Otherwise also we used to assume P was the fixed point. Q I used to move. Okay, Q I used to move either this way or this way, so as to give certain inclination to VP also. Now it is inclination to HP is 30 degree. So as to give some inclination to VP, I used to move this way or this way. Whatever they are given, I used to move. Okay. In that way, yes, a line was inclined to both HP and VP. And when you move Q this way or this way, there was only one locus in the front view. That is Q locus in the front view, as well as Q locus in the top view. That means there was only one locus. Okay. That is Q locus in the front view or Q locus in the top view if it is inclined to VP and all that. Okay. But you see here, let us say this is the thing. In this way, you see here, I have given a typical problem where line is AB, you imagine. Okay, please carefully follow. Line is AB, some 40 mm above HP, whatever is that and all that. Line is AB, is red one, capital AB. This is for this corresponding front view was A dash B dash, corresponding top view was AB. Okay, corresponding top view is AB. Now, midpoint is M. That is midpoint of AB is M. If M is the midpoint, corresponding front view of this M is M dash here. That is in between A dash B dash. Corresponding top view of M is, this is M, small m. That is in between AB. Okay. Now you see here, keeping 30 degree to VP constant. Okay. Okay. It is parallel to HP. It is parallel to HP. Now, keeping 30 degrees to VP constant, okay, if I move, I'll move, my fixed point is M now, not end point. When it is the midpoint, it is, when they refer the midpoint, you have to fix the midpoint only. When you fix the midpoint, and if you start giving inclination to some HP, if I move this up, A comes down. That means there will be locus of A as well as locus of B. Okay, that means when you start giving inclination here with respect to HP, if you see here, let us say I'll move this up. Okay, as long as constant inclination to VP is maintained. If I move this up, if it is moved up, A comes down. Can you understand? In that way, that front tube might remain same because as long as inclination to VP remains same, the front tube might remain same. But what exactly happens is the B moves up, A comes down because A is not a fixed point. M is a fixed point. As a result, both A and B are moving points. Okay, that is why I have given here clearly. If M is a fixed point here, midpoint, M is a midpoint in fact, then if I start rotating, this locus of A will be there, locus of B also will be there. That means A will be moving on this locus, that is for different positions of B. B will be moving on this locus for different positions of B. That means when you start giving inclinations to HP. Okay, when you start giving, now it is parallel to HP. Once you start giving inclinations to VP, when you start giving inclinations to HP, okay, A will start moving this way, B will start moving this way and all that for final positioning of the top view and front view and all that. Okay, please be careful. I'm telling you again, this has the midpoint as the reference point. The midpoint distance they'll give. Midpoint now it is 40 mm in front of VP, 40 mm above HP, line measures 60 mm and is inclined at 30 degrees to VP. That's what I have written here. Okay, midpoint is some 40 mm above HP, 40 mm in front of VP, line is inclined at 30 degrees to VP. Okay, and it is parallel to HP. Okay, in that way you have a locus here, locus here. Please understand, when you with M as pivot, that is M as the fixed point, if you start giving inclinations to, this is VP, when you start giving inclinations to HP, when you start moving up here, when B moves up, A comes down. That means this A also starts moving, B also starts moving. As a result, it is called double locus problem. Okay. Now we'll do one simple problem in this way. See here, I have told you midpoint of this problem is midpoint of a line AB is 40 mm from both the planes. Take M dash and M. Okay. I think this is not a problem. Okay. Line is here. Line is inclined at 100, line measures 100 mm and is inclined at 30 degrees to HP. Okay. Then since it is a midpoint, you have to do carefully. You do 50 mm this way, 50 mm this way at 30 degree in that way, so that totally it is 100 mm. Now M dash and M you locate. M dash B1 dash you draw 50. Then in the same way, M dash A1 dash also you draw 50. Okay. Totally it is 100 mm. Draw locus here, draw locus here. This is very important. Midpoint problems are sometimes referred to as double loci problems. Okay. Okay. Now this is M dash B1 dash 50 mm you take. M dash A1 dash you take 50 mm. In that way, you complete the true length. The line is inclined at 30 degrees to HP, not with one end point, but with midpoint. Okay. Once this is 40 mm anyway. Once true length is found, corresponding other view, parallel to XY line you do. Procedure remains absolutely same. Same way you do. Okay. Then once it is a true length, corresponding top view parallel to XY line, which you can rotate till it cuts the end projector or locus and all that. We'll come to that. Next, line is inclined at 45 degrees to VP also. Okay. Same 50 mm, no? Totally 100. Line is inclined at 50 degrees to VP. With MS center, 50 degrees you draw. 45 degree, 50 mm you take here, and back also 50 mm you take. So that A to B2 is the true length of the line inclined at 45 degrees to VP. Here A1 B1 was the line, okay, inclined at 30 degrees to HP. Okay, A1 dash B1 dash is the front view, corresponding top view was parallel to XY line. Now you have written A to B2, which is the true length. Okay, true length. MB2, MA2 in that way written. When it is true length, corresponding other view should be parallel to XY line. You draw immediately corresponding other view parallel to XY line. A2 dash, B2 dash you write. Okay. Now once you draw this, the skeletal part of the work is over. See here, now I am telling you. First you have drawn A1 dash, B1 dash, no. M dash B1 dash, M dash A1 dash 50, 50. In that way, you have written the true length. Corresponding other view parallel to XY line, which you can rotate. Now, when you have to rotate, you can't take A1 as center because this is also a moving point. This is also a moving point. You have to rotate with M only. That is why M as center, MB1 as radius, I'll draw an arc. Okay. I'll draw an arc till it cuts the locus. In the same way, once B1 is going this way, A1 will be coming this way. M as center, MB1 as radius, draw an arc to cut the locus. In the same way, M as center, MA1 as radius, draw an arc to cut the locus here. Okay. Then you get AB. The line joining A and B should pass through M. Okay. Now you see here. Now M as center, MB1 as radius, draw an arc to cut the locus. M as center, MA1 as radius, draw an arc to cut the locus. These are all same thing what you are doing earlier, but only thing is since it's midpoint, there will be two loci, one for A, one for B. In that way, you have to take care of this procedure. Okay. Now anyway, now once you do, line joining A and B must pass through M if you are done correctly. Okay. This is the top view. Okay. This is the top view. Now, as you know here, this 40 mm can be anything. It is not a parameter. The three parameters what they are given is true length is given, theta is given 30 degree, phi is given 45 degree. Okay. Now with keeping inclination of 30 degree constant, you move the line to 45 degrees to VP also, so that the when you see the front view also, it is not seen in true length, apparent length it will be. When you see the top view also, it will be apparent length. Now top view I have already written, it is an apparent length. Okay, this is alpha. Now once you get A and B here, take the projectors up. Okay, take the projectors up. You see here from A dash here, B dash here. In that way, you join A dash, B dash, so that the front view is obtained. Front view is obtained. This is alpha. This is beta. That has to be recorded. Okay, this has to be recorded, and you have to put it separately here. Okay, this is a problem 24 from VTO. Okay. Now, what I suggest here is, here, first you draw XY line, VP, HP, locate M dash M, that is not a parameter, whatever they give, you take. 40 mm means 40, 50 mm means 50, 40, 60 means 40, 60, in that way, whatever they give above HP in front of VP, you take. Locate M dash and M. Once you locate M dash and M, I'm doing revision, line is inclined at 30 degrees to HP and measures 100 mm. Since it is midpoint, you have to do half. 30 degree this way, 30 degree this way, 50 you cut this way, 50 you cut this way. In that way, A1 dash, B1 dash you get. Immediately, when true length is found in the front view, corresponding top view should be parallel to XY line, A1, B1 you draw. Okay, corresponding top view, A1, B1 you draw. In the same way, with MS center, draw MB2, MA2. Okay, MB2, MA2 at 45 degree, cut 50 here, cut 50 here. Okay, once you cut 50 and 50 here, that this is the true length of the line. I have told you when you find the true length, corresponding other view should be parallel to XY line. Immediately write the corresponding other view, A2 dash, B2 dash, parallel to XY line you draw. Okay, A2 dash, B2 dash, parallel to XY line you draw. Now you see here, you already got the locus here, double locus. You already got the locus here, after drawing 30 degree, 45 degree line, you have already got the loci here, double loci problem. Then M as center, MB1 as radius, draw an arc to cut the locus, you get B. M as center, MA1 as radius, draw an arc to get the point A. Then join A and B, the line has to pass through M only if you are done correctly. This is the top view of the line, when the line is inclined at 30 degrees to HP, 45 degrees to VP. Okay. Then take the projectors up and draw the corresponding front view. This is a very good problem, what they keep giving in the exam. Unless you know the basics, you can't do such problems. Please practice. Okay. Now we come to the end of session 11. We'll continue this in session 12. Thank you viewers for watching. Thank you. Thanks again.